lesson on units of measure. In this video, we will discuss various units of measure, and we'll also introduce the SI system of measurement. To begin, let's define what a measurement is and what it actually means to measure something. Well, in science, a measurement is considered the assignment of a numerical value to an object's physical property. Measuring physical properties such as length, volume, and density is very common. For example, you might want to know the length of a line, the volume of a sphere, or the density of a liquid. Whenever we take measurements, we also have to assign units to the numerical quantity in order to convey the relative size or magnitude of the property in question. For instance, if I said the length of my shoe was 10, you wouldn't actually know how long my shoe was because there would be no context for what the 10 represents. In fact, this measure would only make sense if the number 10 had a unit of measure to go along with it. So what is a unit of measure? In order to have accurate and reproducible ways to define magnitudes of length, volume, density, etc., scientists have developed various systems of measure. These systems are made up of units of measure, which are basically standardized amounts of various physical quantities. The SI system is the international system of measure used by scientists. It is a very comprehensive system with many units of measure. However, we will only need to cover a few of these units in order to prepare for the T's. The fundamental physical properties you will need to know for the T's are as follows: mass, length, temperature, and time. You can see that for each property there is a mathematical label which is used in formulas, and the actual name of the corresponding SI unit or measure. Please feel free to pause the video and familiarize yourself with the information on this chart. Notice that the chart refers to these units as base units because they help to define more complex units, which are called derived units. For example, area is a physical property that uses a unit called meters squared. Since meters squared requires the meter in order to be defined, it is considered a derived measure or unit. Let's walk through an example that will illustrate how the meter is actually used to define area in meters squared. If we take a line that is 2 meters in length and then create a square from 4 of these same lines, we can find out the area or two-dimensional space that this square occupies by squaring the length of the original line. We're not going to talk about the math concept of squaring in much detail here, but just know that in essence, we're multiplying a base length measurement by another base length measurement, which is 2 meters times 2 meters.
Hi, I'm Miss Rocket. Welcome to Classroom Science. Fundamental and derived quantities. In our daily life, we use measurements many times. Can I get 2 kilograms of tomatoes? I ran about 3 kilometers today morning. Here, 2 kilogram and 3 kilometers are physical quantities. And these quantities are expressed as value with unit. Every measurement is expressed only in this pattern, value with unit. When we talk about physical quantities are of 2 types in general. They are fundamental quantities and derived quantities. Fundamental quantities. Quantities which deal with basic measurements and quantities which cannot be expressed in any other quantities are known as fundamental quantities. There are 7 fundamental quantities in System of International Units. They are length, mass, kilogram, time, temperature, electric current, amount of substance, and luminous intensity. Length is expressed with the unit meter. Mass is expressed with the unit kilogram. Time is expressed with seconds. Temperature is expressed using Kelvin. Electric current is expressed using ampere. Amount of substance is expressed with the unit mole. Luminous intensity is expressed using candela. So, here we have fundamental quantities to measure. Do you think it is possible to measure everything in the world just using fundamental quantities? Two boys are riding bicycle. To find which boy's bicycle is the fastest, we should consider the time taken and distance covered by them. So, to calculate the speed of bicycle, we use two quantities, distance and time. Here we calculate speed with the combination of distance and time. So, speed is a derived quantity. Any quantity which is a combination of fundamental quantities are called as derived quantities. In general, derived quantities are obtained by multiplying, dividing, or combining fundamental quantities. Examples of derived quantities are area, volume, speed, electric charge, and density. Area. Area is a combination of length and breadth. So, the unit of area is meter square. Volume is equal to length into breadth into height. So, the unit of volume is meter cube. As area and volume are obtained by combining two or more fundamental quantities, they are derived quantities. Thank you.